Hello and welcome. Here we have this challenge. It's a simple one, okay? Simple exponential challenge. The question is 2 to the power of x plus 1 equal to 2 plus 2 to the power of x minus 1. What is the value of x? Here we are asked to look for the value of x. And I've solved this challenge. I discovered that at the end, we cannot actually get an exact figure that when we substitute here and here, will give us an accurate answer. So whatever we're going to have from this solving will give us an approximate value. Okay? All right, so how do we go about solving this? We first of all rewrite this expression here and also rewrite this expression here. So doing that, we are going to apply the law of indices, which says that your a to the power of your m plus n is same thing as your a to the power of your m times your a to the power of your n. Okay, so we can rewrite this and rewrite this. So this is going to give us our 2 to the power of x times our 2 to the power of 1 equal to 2 plus this will give us 2 to the power of x times 2 to the power of minus 1. Now, this is in negative power. We apply another law again, which says that your a to the power of minus m is equal to 1 all over a to the power of your m. So if we do that, we're going to have our 2 to the power of x times 2 to the power of 1 equal to 2 plus our 2 to the power of x times 1 all over 2 to the power of 1, which is same thing as 2. We have to eliminate this denominator. We multiply each of these terms here by 2 to the power of 1. And 2 to the power of 1 is 2. And so this also gives us 2, right? So we're going to have here 2 to the power of x times 2 times 2 equal to 2 times 2 plus our 2 to the power of x times 1 all over 2 times 2. And so this and this will leave. We now have this to be our 4 bracket 2 to the power of x close bracket. This is equal to 4 plus our 2 to the power of x. Easy. All right. Now what do we do? We are having 2 to the power of x here. We are having 2 to the power of x here. We can do a simple substitution, but that substitution is of no value. In other words, look what I said, let 2 to the power of x represent a different alphabet, but that is meaningless or baseless. And so we move this quantity to this side. Here we have a plus, and when it crosses the sign of equality, it turns to minus. And so we're going to have our 4 bracket 2 to the power of x close bracket minus 2 to the power of x equal to R4. This is just a bracket. This bracket here also means multiplication. So this could be written as your 4 times your 2 to the power of x minus 2 to the power of x equal to 4. Now, something is common to what we have here, 2 to the power of x. We have to factor out 2 to the power of x from here and here, since it's common to both quantities. So from here, we now have here 2 to the power of x bracket. If we use this to divide this, we are left with our 4, then minus. We use this to divide this, we are left with 1, close bracket, everything equal to R4. Here we are having 4 minus 1, right? So we can carry out our subtraction. And if we do that, this is going to give us our 2 to the power of x, then into our 3, then equal to our 4. Let's continue on this side. Okay, mind you, we are looking for x. So the best thing to do here is to eliminate this 3 here. We divide through by 3. So we have 2 to the power of x times our 3 all over 3 equal to our 4, right? All over our 3. This will leave. So we now have 2 to the power of x is equal to 4 all over 3. Okay. Now, from here, we just have to eliminate both sides of the equation. Okay, so our 2 to the power of x is greater than 0, or must be greater than 0, right? Good. So we have here 2 to the power of x is greater than 0. So if it is so, then we cannot have a negative value from this expression here. Okay, so we're going to ln both sides of the equation. So we have the ln of 2 to the power of x is equals to the ln of 4 all over 3. Let's put this in bracket. Wow. Here we have the power here. So we're going to apply the power law of logarithm, and we're going to apply the division law of logarithm too. The power law says that when you have the ln of your a to b to the power of b, we have to move this to this side to give us our b times the ln of a. Then the division law for this other side says that when you have the ln of your, this ln please, the ln of your a all over b, this is equal to the ln of a minus the ln of b. So let's apply these two rules here. So we're going to move this to this side. So we have our x times the ln of 2. This is equal to, here we're going to have the ln of our 4 minus the ln of 3. Easy. Because we have ln of 2 here, and we can express 4 as 2 to the power of 2, then we just have to rewrite this. So this is going to give us our s times the ln of 2 is equal to the ln of 2 to the power of 2 minus the ln of 3. Easy. All right. Again, we apply the power law to this to give us x times the ln of 2 is equals to 2 times the ln of 2 minus the ln of 3. All right. Now, we are looking for s, so we divide by the ln of 2. So we divide by ln of 2, we divide everything here by ln of 2. So this leaves the system. We now have our x will now be equal to, we can rewrite this expression we have here now. This is the same thing as our 2 times the ln of 2 all over the ln of 2, then minus ln of 3 all over the ln of 2. This expression here is same thing with what we have in here now. These are common, so this and this will leave the system, right? So we are now having our x standing on its own. So we now have our x, therefore will now be equal to 2 minus the ln of 3 all over the ln of 2. So we can get the numerical value for the ln of 3 and that of 2. So the ln of 3 is 1.099, and that of ln of 2 will give us 0.6931. So rewriting this, we're going to have our x is equals to 2 minus our 1.092 all over 0.693, right? Okay, so 3,1. So let's put it here to, okay, 3,1. So we can easily divide that, and if we divide that, will give us 1.586. So we have our x is equals to 2 minus 1.586. Easy. What if we subtract this now? What will this give us? It's going to give us 0.414. So we have, therefore, our x is equals to 0.414. So this is the value of x that will actually satisfy this original equation. But if you input these values into this system, you're going to have what is called the approximate value. Not exact values, but it's an approximate value, very, very close to each other. All right. Now, here we have a challenge before us. Here, the question is a wonderful one. It's a nice one. Here we have a triangle and a circle together. The circle is inscribed inside the right-angled triangle. And we have triangle ABC, giving the size, small letter A is 21, the small letter B, which is the opposite, is 28, and small letter C is 35, the hypotenuse. Now, we are asked to find the radius of this circle. Now, if you take a look at this critically, O is the center of the circle. So, is there any relationship between the inscribed circle and the triangle itself? Yes, there is a relationship. Why or how? If you check this inscribed circle, you discover that this circle is touching the hypotenuse, is touching the adjacent, and it's also touching the opposite. Okay, so since it's touching all three sides of the triangle, then there is a strong relationship between this circle and the triangle. Yeah, I'm going to use two methods in solving this challenge. Okay, and the two methods are wonderful. In fact, the last one is very beautiful. So I urge you to stay from the beginning to the end of this math class, even as I take you on this journey. So let's take our solution. All right, so we take our solution. Before we continue, if you've not subscribed, consider subscribing. And when you subscribe, turn on the notification bell because we release videos all the time. Yeah. All right. So now, given this side here, let's bring out the value of A, B, and C. So from here, let's take the quantity given. So given, we have our small letter A is equal to, look at it, it's 21. Then our small letter B is equal to 28. And our small letter C is equal to our 35. Okay, the angles are not given apart from angle C, but we are not bothered about that, right? Good. Now here we're going to use a very nice relationship. We all know what is called the Hero's formula. The Hero's formula is used to calculate the area of a triangle when it is a scaly triangle, okay? All right, so when the height is not given, we use the Hero's formula. And if you are familiar with the Hero's formula, there's what we call X, and X stands for the semi-perimeter of the triangle. And how do we find the value of X? We know that X is equal to A plus B plus C all over 2, right? So there is a strong relationship between the semi-perimeter of this triangle and the radius of the circle inscribed inside. Okay, so how do we now find that? So first of all, let's find our X, which is the semi-perimeter. So we have our X is equal to, we know that is A, then plus RB plus C all over 2. This is the formula for our semi-perimeter, right? So let's go ahead and substitute. Our A is 21, then plus RB is 28, and RC is 35. So we have 35, then everything all over 2. So let's add up and see what this gives us. 5 plus 8 will give us 13. 13 plus 1 will give us 14. Carry 1. Then 3 plus 2 will give us 5. 5 plus 2 will give us 7. Plus the 1 you carry will give us 8. Everything all over 2. So if we divide down, this will give us 42. So our X is equals to 42. Here comes the relationship that exists between semi-perimeter and the radius inscribed in. So from here, our radius can be calculated towards radius radius arrow will be equal to our X, which is the semi-perimeter, then minus our C, small letter c. Okay, so the X calculated for is what? 42, and our side C is 35. So have here 35. So if you subtract this, this will give us our 7. Okay, so therefore our radius is equals to 7. This is the first method, very straightforward, right? Now the second method to calculating the radius of this very inscribed circle is this. Now we have our A, B, C. So first of all, let's take here second method first. Second method. All right. Again, this one is the first method. This is first method, please. All right, let me state it. First method. All right. Now, in the second method, we have to go back to these values again. We're going to make use of only these values, not going to consider the semi-perimeter. And what is the relationship? The relationship, between this and the radius is this. So we have our radius arrow is equal to a times b all over a plus b plus c. That is just the relationship. Yeah. Okay, so let's go ahead and multiply. What is our a first? Our a is 2 1 times, what is our b? Our b is 28 all over. Then our a, we have 21 plus 28 plus 35. So let's multiply and see this. Our 28, let's take it here, 28, the times our 21. 1 times 8 will give us 8. 1 times 2 will give us 2. 2 times 8 will give us 16, carry 1. 2 times 2 will give us 4, plus the one you carry will give us 5. So if we add up this will give us 8, 8, 5. So we have 5, 8, 8. So we have 5, 8, 8 all over. If we add up this, that is what we did here already. That will give us 84. Now, if you divide this out, it's going to give you 7. So therefore, our arrow is equal to same 7. Now look at what we got in the first method. We also got what? 7. So either you use this method or you use this method, you get the same answer. Okay, so this brings us to the end of this wonderful math class. The radius to this circle is 7. If you learned something from this video, drop it in the comment section. You have a better way of solving this challenge, saving time. Drop it in the comment section. Also, check out this challenge here. We have the cube root of x plus the square root of 2 equal to 2. Now, I have solved some challenges of this kind, but the radicals are of the same radical. And so, when you have the radical to be the same, you can square this side and square this side if it is a square root radical. Or you move one of the quantity to this side, then square both sides of the equation. But the difference between the ones I've solved and this one is this. Look at the radical here. Here we have a cube root radical, and here we have a square root radical. So they are different. And so that method of, squaring this side or take the cube of both sides without transferring one of the radical to the other side would not work here. So the only method we can use in solving this is to separate the radicals. Okay, now this one is the one having the variable we are solving for, and so move this one to this side of the equation. Okay, so stay to the end, because at the end we're going to verify if the answer we're going to solve for we actually satisfy the original equation. And so let's take our solution. So we have the solution. All right. Now, I said because they are different radicals, send this to this other side. So this is going to give us the cube root of our x will now be equal to 2 minus the square root of 2. This is simple, right? We can easily eliminate this radical by taking the cube of both sides. So if we take the cube of both sides, all right, this and this will leave, right? So from here, we now have our x, open up. X will now be equal to, so let's expand this. We can rewrite this power here. And so this can be written as our 2 minus the square root of 2 all raised to the power of 2 plus 1 as the power, right? Now, according to the law of indices, we can rewrite the whole of this expression. Remember, the law which says that when you have your a to the power of m plus your n, what does it mean? It means that your a to the power of your m there times your a to the power of your n. Because these are the same, so we add the powers, right? So I want to rewrite this expression here. So rewriting this is going to give us bracket 2 minus the square root of 2 close bracket to the power of 2, then times bracket 2 minus the square root of 2 raised to the power of 1 here. Okay, Now we can easily open up this, right? Or we could as well use the binomial expansion to open up this, but still we'll get the same answer. So let's open up this first. So if we rewrite this very expression we have in here, this is going to give us 2 to the power of 2, which is 4. Then minus is going to give us 2 bracket our 2 times root 2 close bracket. Then this will now give us plus the square root of 2 all raised to the power of 2. Okay, because here we have 2 raised to the power of 2, which is already 4. And so if we open up this, again, we still have this other side. Okay, let's still include this side minus the square root of 2. Okay, so here we're going to have 4. If we open up this, we're going to have minus 4 root 2, then plus our 2, because this will leave in bracket, 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 2 minus root 2. We can add this and this together. So we now have our 6 minus 4 root 2 bracket, bracket, our 2 minus root 2. So we can now use this to open up this again. So if we do that, 6 times 2 will give us 12. 6 times minus root 2 will give us minus 6 root 2. Then minus 4 root 2 times 2 will give us minus 8 root 2. Then minus 4 root 2 times minus root 2 will give us plus our 4 root 2, right? Yes, minus 4 root 2, then times root 2. All right, so let's go gradually. So this is going to give us our 12. We can simplify this expression here. If we do that, this is going to give us minus 14 root 2. Now we are having root 2 times root 2, and that will give us 2. And 2 times 4 will give us plus 8. So let's continue on this side. So we can add this and this together to give us 20. We have our x on this other side. We have 20, then minus our 14 root 2. What is common here is 2. We can factor out 2. So if we factor out 2, we're going to have 2 into 10 minus 7 root 2, close bracket. So we have our x, therefore, is equal to 2 bracket 10 minus 7 root 2, close bracket, right? Good. Now, what is then the numerical value that when we put it in here, simplify it, it will give us this. So if you simplify this, we're going to have our x is equal to our 0.2010 approximately. Okay, so let's check if this will satisfy the original equation. So we take our check. So we have our equation, which is the cube root of x plus the square root of 2 equal to 2. This will give us the cube root of our x is 0.2010, right? There plus the square root of 2 equal to 2. Now, if you simplify everything we have in here, this is going to give you 1.9999990 and some other figure. This is approximately 2. So this is the answer, and it shows from this verification that this actually satisfies it, but though it's not an exact value, very, very close to the answer. And so this is proof that the answer x equal to 2 brackets open 10 minus 7 root 2 close bracket satisfies the original equation. Thank you for being there. Hello everyone, welcome to today's class. Today we have this challenge on the board. It's an unusual question, and I like exploring unusual questions, okay? The question was produced some time ago, okay? I made a video on this challenge, but I just have to take in that to bring a clearer version of it. The question is 16 to the power of x plus 8 to the power of x plus 4 to the power of x plus 2 to the power of x plus 1 equal to 0. What is the value of x that will satisfy this challenge here. Okay, so let's take our solution. Here we're looking for the value of x. We're asked to look for the value of x here. So what is the value of x? We take our solution from here. So solution. Now you discover that here we are having 2 to the power of x. And the beauty of this question or in this challenge is that 4 can be expressed in base 2, 8 can be expressed in base 2, and 16 can be expressed in base 2. So let's go ahead and express all this quantity in base 2. So this is going to give us our 2 to the power of 4, all raised to the power of x, then plus 2 to the power of 3, all raised to the power of x, plus 2 to the power of 2, all raised to the power of x, plus r2 to the power of x, plus 1 equal to 0. Now, look at this number we have here. We are having 2 to the power of x here, right? We want to achieve same in the brackets we have here. So we want to force this x inside. In other words, we want to push the x inside and push this figure here outside. We are going to apply a simple law in indices which says that when you have your e to the power of, let's take p dot q, then this could be written as a to the power of p, or in bracket raised to q, or our a to the power of q, or in bracket raised to p. Okay, so we're going to interchange this now. So this will be written as 2 to the power of x, bracket, bracket, our 4, then plus 2 to the power of x, bracket, bracket, 3, then plus 2 to the power of x, bracket, bracket, 2, plus 2 to the power of x, plus 1 equal to 0. So you discover we are having 2 to the power of x all true here now. Okay, so we're going to do a simple substitution here. Okay, so let's bring in another alphabet to represent this 2 to the power of x to give us a different equation. So let's bring a closer alphabet to our x. So let's take y. So you're going to say let our 2 to the power of x be equal to our y. So wherever we see 2 to the power of x, we want to put in y in there. So this now implies that our equation will now becomes our y to the power of 4 plus y to the power of 3 plus y to the power of 2 plus our y, then plus our 1 equal to 0. So this is a 4th degree polynomial equation where we have to solve for 4 roots or 4 values of y that will satisfy this equation. Now, we cannot use the trial by error method in solving for this challenge here. So the only way we can use or we can apply in solving this is to think of something else. Now, from this place here, you discover that if you decide to divide through by 2, you're going to have an algebraic identity. And from that algebraic identity, you would be able to solve for the value of our y here. From there, substituting into this to give us a correct value for x that will actually satisfy this equation. And so what we do, we think of our geometric series or geometric progression. What does it say? It says that your a plus your a arrow plus a arrow to the power of 2, then plus a arrow to the power of 3 plus our dash, then our plus our a arrow to the power of n minus 1. You remember this? This is from your geometric series, right? Good. So if we have this expression to be this will now be equal to what? And so we can now take this to be equal to our a arrow to the power of n minus 1 all over arrow minus 1. Wow. Remember this expression? Good. So if you remember this expression, now we can liken this expression to what we have in here now. Look at this. And look at what we are having here. Okay, decrease it down to we have one here. Now, so let's look at our question. If we now relate this to this, what will be the format of this expression in this form? What will be the form of this expression in this form? It's going to give us something of this. So it means that our y to the power of 4 plus y to the power of 3 plus y to the power of 2 plus our y plus 1, this is equal to, look at it carefully. What is our a and what is our arrow? If you check carefully, a is equal to 1 from this expression and arrow is equal to ry. Okay? Okay, so a is equal to 1 and arrow is equal to y. So if it is so, then we can now bring in this format for this. So this is going to give us our y to the power of 5 minus 1 all over y minus 1. Why are we saying this is to the power of, look at this is to the power of 4 and we're having this to the power of 5. Look at our expression we have here. Okay, n minus 1. Okay, so hence this y will be to the power of 4, and if this to the power of 4, this will be to the power of 5. That is a simple logic, right? Okay, so from here, we are having the whole of this equation to be equal to 0. So this is equal to 0. So we can now rewrite this expression to give us something unique here. So taking this, it now implies that our y to the power of 5 minus 1 all over y minus 1 is equal to 0. Now, if you take a look at this challenge here, y cannot be equal to 1. Okay? Y cannot be equal to 1. Why? Because we cannot divide by 0. If y is equal to 1, then the denominator is going to give us 0. And that would be y to the power of 5 minus 1 all over 0, which is undefined. And so, what we do here, we multiply it through by y minus 1. So if we do that, we're going to have y to the power of 5 minus 1 is equal to 0. Move this to this side of the equation, so we have y to the power of 5 is equal to positive 1. Never make the mistake of taking the fifth power of both sides of the equation. How? Because that will give us what? 1. And we've said that y cannot be equal to 1. So what we do here, we think of another method of solving for our y. And what is that method? We're going to evoke the Euler equation. And what does Euler equation says? It says that your, let's put it here, your e all to the power of your pi iota plus 1 is equal to 0. So if we move on to this side, we're going to have e to the power of pi iota is equal to minus 1. But here we have plus 1. So what we do? We're going to raise both sides of this equation to 2k, where k is a constant ranging from 0, 1, 2, 3, down, right? Good. So from here, this is going to give us e to the power of our pi, here, all raised to the power of 2k, there, equal to minus 1, all raised to the power of 2k. Now, if we apply this rule here, we can shift this in, or we can raise this to minus 1 to the power of 2, all raised to k, and that will give us what? Positive 1. And 1 to the power of k will give us what? 1, which is positive 1. So in other words, we're going to have our e to the power of our 2k pi iota, okay, equal to our 1. We come back to our original equation here. So we can substitute the whole of this expression we have here in place of 1. So we now have our y to the power of 5 is equal to r e to the power of 2k pi iota. Are we getting something here? Yeah, let's separate this out here, please. Okay. Now, with what we have here now, we want to take the sixth power or the sixth rule. So this is going to give us our fifth. So we'll have 5 all raised to the power of 1 all over 5. This is equal to re raised to 2k pi iota. Okay. Let's erase. So this ri all raised to 1 all over 5. This leaves the system, so we now have y is equal to our e raised to the power of 2k pi iota all over 5. Easy. All right. So with this now, we have our k to be what? Because to look for 5 roots here. So meaning we have here our k is equal to 0, 1, 2, 3, and we stop at 4. Because this is going to give us our y1, y2, y2, 3, y4, y5. Right? Now, if we substitute our y0 into this system, this is going to give us 1. And remember we said y cannot be 1. So we're going to ignore the first value here, which is k equal to 0. We'll start from this other side. But again, now we have our y to be this. What is now the value of our x? So we remember where we said let 2 to the power of x be equal to y. So let's do the substitution here and get the value of our y to x to this challenge. So when we recall, we say we have our 2 to the power of x is equal to what? Y. So if we record this, we're going to substitute that into this system. So we have our 2 to the power of x is equal to the first value, or the general equation is this, right? So let's take this is equals to our e to the power of 2k pi I all over 5. Easy. Now we're looking for x, right? So we have to ln both sides of the equation. So if we take the ln of 2 to the power of x, this is equal to the ln of this times our 2 pi k is here, please, all over our 5. Now remember that our ln times e will give us 1. So this is going to give us, we'll be left with 2k pi I all over 5. Easy. Here we have power here. So we apply the law of logarithm, which says that if you have your ln of a to the power of your b, this is equal to b times the ln of a. So if we apply that, we're going to move this x back to this side here. So if we do that, we're going to have our x times the ln of 2 is equal to 2k pi iota all over our 5. We are looking for x, right? So we divide by our ln of 2. So divide by ln of 2, we equally divide this side by the ln of 2. This will leave. So we now have our x will now be equal to, now if we use this to divide this, we're going to come up with our 2k pi iota all over 5 times the ln of r2. Wow. So this is the value of our x that we give us, or that we satisfy this equation. But mind you, we have about 5 roots to this challenge here, and we said our k cannot be 0 based on this condition. So we're going to start from this one here. So what is now the value of our x1, x2, x3, x4, x5? Knowing that x1 is already out of the system, so starting with this, so we're going to have our x1 will now be equal to what? So we are going to substitute for k. K is going to be what? 1. So when k is 1, what will be our x1? Our x1 is going to give us 2 pi iota all over 5 ln of 2. This is our first value for our x. All right, so let's go ahead and solve for our x2. What is our x2? Our x2 is going to give us, so we're going to have our k to be 2. So if we put that into this original equation, this is going to give us our 4 pi iota all over our 5 ln of 2. Wow. So our x3, so we're going to have x3, we're now going to take this, which is going to give us our 6 pi iota all over 5 ln of 2. And our x4, which is the last one, this is going to give us times 4 to give us 8 pi iota all over 5 ln of 2. So these are the values of x that will satisfy this equation. In other words, the 4 roots we solve for the value of x, they are all imaginary roots. All right, so this brings us to the end of this math class. If you learned something from this video tutorial, do not forget to give the video a thumbs up. Okay, thank you for being there. This is Online Maths TV. Hi, check out this challenge here now. The question is x all over 7 equal to x. What is the value of x here? Let's take our solution and see how to solve a problem of this kind. So we have x all over 7 is equals to x. Anytime you have a fraction of this kind, try as much as possible to eliminate the denominator. And how do we eliminate this? We multiply both sides of the equation by 7. So this is going to give us x all over 7 times our 7. This is equals to x times 7. This will leave. So we now have our x is equal to our 7x. This is the reason why I decided to bring this challenge here. If we decide to cancel out x here, x here. In other words, if we decide to divide through by x, we'll be left with 1 will now be equal to 7. But you and I know that 1 is not equal to 7. So that will not work out. And that's why I said in some of my videos, I always point this out, that when you have a challenge of this kind, or you're solving a mathematical challenge and you come across a step of this kind, quickly move this quantity on the right hand side to the left hand side, or the quantity on the left hand side to the right hand side, depending on which is greater. Want to move this quantity to this side of this expression, so this is going to give us 0. But how do we do that? Now we just have to subtract x from both sides of the equation. So we're going to have x minus x is equals to about 7x minus x. Then plus x minus x will give us 0. So we have 0 equal to 6x. Okay, good. We are looking for x, right? So let's rearrange this arrangement. So we're going to have 6x is equal to 0. Because we are looking for Rx, what we do, we divide through by 6. So let's divide through by 6. So we divide this side by 6, we equally divide this side by 6. 6 here, 1, 6 here, 1. 0 all over 6 will give us 0. And so we're going to have our x is equal to 0. So 0 is the only solution to this challenge here. So if I put in 0 here, 0 all over 7 will give us 0. And on this other side, we have 0. Okay? Again, remember that there is difference between 0 all over a number, let's say all over 7, and 7 all over 0. These two things are not the same. Okay? This will give you 0, but this is undefined. In other words, it's indeterminate. Okay? How do we solve this kind of challenge? Now, I'm going to use two methods. The first method will give us just one root to the challenge, while the other method will give us 2 roots. So watch from beginning to the end so that you see the other one that will give us the 2 answers to this challenge. All right, so we take our solution. So the question is x equal to the square root of x raised to the square root of x. So we're taking the first method. All right, now the first thing we're going to do here is this. In applying this first method, let's take down the question. We have x is equal to the square root of x or raised to the square root of x here. Good. We have to rewrite this radical here. Okay, so rewriting this radical, this will give us x is equal to our x to the power of 1 all over 2, or in bracket raised to x or raised to 1 all over 2. Now, we can apply the law of indices here to use this to multiply this, because this is power, this is power. The law which says that when you have your a all raised to the power of m times n, this is equal to your a to the power of m in bracket your raised to n, which is same thing as your a to the power of your n in bracket raised to your m. Okay, but here we have this as a fraction, so we use this 1 all over 2 to multiply this. So this is going to give us our bracket, our x, right? Then we have our, let's still keep this in bracket, so we have 1 all over 2 times our x raised to 1 all over 2. So this will give us x is equal to our x raised to power x raised to 1 all over 2 as the power, right? Now the next thing we're going to do here is to ln both sides of the equation. That is ln base e. We can equally take log base 10. But here I want to use ln base e. They will both give us the same answer. Okay, so if I ln both sides of the equation, we're going to give the ln of x is equals to the ln of x raised to our x raised to power half all over 2. Now the whole of this is the power here. So according to the law of logarithm, it says that when you have your ln of your a to the power of b, move this b back here. So this is going to give us our b times the ln of our a. So we want to move the whole of this power to the back here. So this is going to give us our ln of x is equal to our x to the power of 1 all over 2 then times the ln of x. All right. Now we can divide through by ln of x because here we have ln of x, we have ln of x. So if we divide through by ln of x, so let's divide this by ln of x, equally divide everything here by ln of x. So this leaves this one. So we are now going to have here, our 1 is equal to our x to the power of 1 all over 2 times 1. So if we rearrange the system, it's going to give us our x to the power of 1 all over 2, everything all over 2 equal to 1. So we multiply both sides of the equation by 2. So this is going to give us x to the power of 1 all over 2, then all over 2 times 2 equal to 1 times 2. This leaves. So we now have x to the power of 1 all over 2 is equal to 2. We are looking for x, right? Good. So we square both sides of the equation because this is square root. So now square both sides, we equally square this. This will leave according to this law here. So we now have our x is equal to 4. So this is a value that satisfies the original equation. If we put in 4 here, that will give us 4, and here 4 here, square root of 4 is 2. Square root of 4 is 2, so we're going to have 2 to the power of 2, which is 4. So that means x equal to 4 satisfies the original equation. Now let's look at the second method that will actually give us 2 roots. Because if you look at this challenge, you discover that 1 is also one of the roots. Okay? Plus 1 is one of the roots. But how do we get that plus 1 from this system? So let's look at second method. All right. Now, in the second method, in fact, let me start from this point, okay? Because it's still the same pattern we're going to follow till we get to this point. So getting to this point now, we ln both sides of the equation, right? Good. So let's continue from where we ln both sides of this equation. So from here, now have here ln of our x is equal to the ln of x all raised to our x raised to 1 all over 2. We apply the property of logarithm, which is the power law of logarithm, whereby we move the whole of this back here. So we're going to have here ln of x is equal to x to the power of 1 all over 2 times ln of x. Now, at this point, I've always told my viewers, my subscribers, that when you have a challenge of this kind, never you cancel out these 2 log here, but rather move this quantity on the right hand side to the left hand side. But before that, we are having 2 at the denominator. So let's eliminate 2. Okay, so let's multiply by 2. If we multiply by 2, then it's going to give us, our 2 ln of x is equal to, the 2 will automatically leave this system. So we have here the x there times ln of x. Like I said earlier on, move this to this side of the equation. So we're going to have 2 the ln of x minus x to the power of 1 all over 2 there times ln of x equal to 0. Now, what is common to this expression is ln of x. So we separate out, or we factor out ln of x. So we are now left with our 2 here minus our x to the power of 1 all over 2 close bracket equal to 0. Now, we are having this times this equal to 0. According to the law, we call it zero product law, which says that if you have A times B equal to 0, it means that either A is equal to 0 or b is equal to 0. So we're going to have case 1 from here. Case 1, we're going to take, okay, let's take the first one here. So we have ln of x is equal to 0. Now we want to eliminate this ln base e. So we have to bring e into the system. So we're going to write e, raise it to this, write e, raise it to this. So we're going to have e raised to the ln of x equal to e raised to 0. So because this is ln base e, so it will leave this system. Then we now have x is equal to e to power naught will give us 1. So this is the plus 1 I told you that is by mere speculation is a route to this challenge here. Now, mind you, in our first case, first method, we got 4. How do we get the 4 from this other system? We take our case 2. So from our case 2, that's where we're going to get our 4. Then we write the whole of the equation, which is 2 minus x to the power of 1 all over 2 equal to 0. Then we send this to 0 to this other side to give us here x to the power of 1 all over 2. We have to eliminate this half here. So we raise this to power 2, we raise this to power 2. So this will leave. This will give us 4. So we're going to have x is equals to 4. This is our x2, this is our x1. So this is the first answer we got when we apply the first method. Okay, so 4 and 1 are the possible real solution to this challenge here. Here the question is solve 4 to the power of x plus 4 to the power of x equal to 80. This is a simple exponential challenge. The left-hand side quantity are of the same values. So we can factor one of them out. Okay, but first let's take our solution. All right, so if we factor 4 to the power of x from here, we're going to have this 1 plus 1, which is equals to 80. I believe this is simple. Then, if we sum up this is going to give us 4 to the power of x times 2 equal to 80. Quickly divide by 2, then we also divide this by 2, and so this and this will leave. The 2 here, 1, 2 here will give us 40. So we now have our 4 to the power of x is equal to 40. Now the figures look similar, but here we are having 4 as the base number, and we cannot express 40 in base 4. Neither can we express it in base 2, because we can equally express this in base 2. And so we just have to simplify this down. How do I mean? We can break this down to give us 2 times 2, which is 4, times 10. Okay, so let's rewrite this. This will give us 4 to the power of x is equals to 2 times 2, then times 10. And we know 2 times 2 could be written as 2 to the power of 2, right? Good. So this gives us 4 to the power of x is equal to our 2 to the power of 2 times 10. Now, what's the next thing to do here? It is easy. We want to log both sides of this equation. How do I mean? Because we cannot express this in base 2. And so we want to log everything here and log everything here. And we're going to take the ln, okay? ln base e, or we can equally use log 10 base, log base 10, right? But let's make use of the ln. So from here, if we ln both sides, we're going to give us the ln of our 4 to the power of x is equals to the ln in bracket our 2 to the power of 2, then times 10 close bracket. All right, now let's check this out here. We are having a property of logarithm playing out. We call it the power law of logarithm. On this other side, we are having the multiplication law of logarithm and also the power law also here. But let's deal with the multiplication law first, and here we deal with the power law here. And what does the power law say? It says that if you have the ln of let's take our p all to the power of q Then say move this power to this side, and so this is going to give us our Q times the ln of our P. So we're going to move the whole of this X to this side. Then the multiplication law says that if you have the ln of your P then times your Q, this is equal to the ln of your P plus the ln of your Q. Okay, so we're going to apply that here. So writing these two expressions, we're going to have a X times the ln of 4 equal to the ln of 2 to the power of 2, then plus the ln of 10. Right? Good. So we cannot divide both sides of this equation by the ln of 4. We can equally divide everything here by the ln of 4 also. So this and this will leave. So we are now left with just X on the left hand side. So we have our X will now be equal to this expression we have here. We're going to move this power backward, and 4 can be written as 2 to the power of 2, and we're going to move the power backward also. So this is going to give us our 2, the ln of our 2 plus ln of 10. Everything all over 2 ln of 2. Okay, now we can rewrite this again. If we rewrite this is going to give us 2 ln of 2 all over 2 ln of 2 plus our ln of 10 all over 2 ln of 2. This has not changed, right? Good, because they have a common denominator and we can sum up the numerator and that will give us that back, right? Okay, what we do next here is this. You discover the numerator is same with the denominator. So we're going to have 1, 1 here, right? So we're going to have this to be our 1 plus the ln of 10 all over 2 ln of 10. If you input this into your calculator, this is going to give you 1.6609620, right? Something like that. Okay, so this is going to give us our 1 plus 1.6609620. So if we sum up everything, so we're going to have, therefore, our X is equal to 2.66 approximately. All right. So if you impute this into this equation, it's going to give you the approximate value, very close, very, very close to the very answer here. Okay, it's an approximate value, not an exact value. All right, so this brings us to the end of this class. Hello, everyone. Here we have a simplification before us here. It's a basic simplification. When you have a challenge of this kind, fraction of this kind, how do you simplify this? It is simple. Never you start simplification from this part. Of course, you cannot start from here because you will just get lost. And so you start the simplification from the bottom here, then until you get to this side of this challenge. So let's take our solution. How do we solve this here now? Okay. Oh, what is happening to my shark? All right. So with this, the question is 1 all over 2 plus 1 all over 2 plus 1 all over 2 minus 1 all over 4 plus 5. Sorry, 1 all over 5. So we want to take these 4 plus 1 all over 5 first. So if we take this first, this is going to give us our 4, then plus 1 all over 5. And this is all over 1. So the LCM remains 5. So 1 into this will give us 5. 5 times 4 will give us 20. Here, there, plus 5 into 5 will give us 1. 1 plus times 1 will give us R1. So automatically this 21 all over 5. That is for the whole of this. So now let's pick this, and the whole of this, which is what we solve for here now. So this is going to give us our 2, then minus our 1 all over 21 all over 5. This is equal to, here we're going to have 2, then minus Here we have 1 all over, which is the reciprocal of 21 all over 5. If we change this to division sign, what happened? Then later change this to multiplication again, it will flip this up and this down. And so the whole of this expression is the same thing as our 5 all over our 21. Easy. Again, this is all over 1. So if we find the LCM of this and this will give us our 21. So this is going to give us our 21. Yeah. Then 1 into 21 will give us 21. We use 21 to times 2. And that will give us 42. So we have 42. Then minus 21 into 21 will give us 1. Then we use the 1 again to multiply our 5. That will give us 5. So we have here our 5. So 42 minus 5 will give us 37. So we're going to have this to be 37 all over 21. Again, we are done with the whole of this here now. So we bring this 37 all over 21 under the whole of this. Then we bring this here now. So this is going to give us our 2 plus, we are taking this one now. So we have 1 all over 37 all over 21. So let's continue here. Okay, now let's take a look at this. Again, we apply that rule by changing this to division sign. Again, change it to multiplication, and you discover that this 21 will go up and 37 will come down. So we're going to have our expression, this all over 1. So we're going to have 2 all over 1, then plus our 21 all over 37. Look at it here. Okay, so with this, we find the LCM of this and this again. So if we find the LCM still remains 37, right? Good. So 1 into 37 will give us 37. 37 times 2, that will give us 74, right? Yeah, so we have this to be 74, then plus our 21, because 37 into 37 will give us 1, and 1 times 21 will give us 20. So let's add up this. If we add up everything here, this is going to give us our 95 all over 37, right? This is 7, please. Okay. So now let's look at this here now. We are not through with everything here, which is everything here now. So we want to take this answer, put it under here, and marry it with this. So this is going to give us our 1 all over 2, then plus 1 all over 95 all over 37, which is equal to, again, we just have to flip this over because this is reciprocal of everything here. So I have 1 all over 2, then plus our 37 all over 95. Easy. So the LCM of 2 and 95 will give us 2 times 95, which is 190. So we have 190, right? Okay, so this now give us here our 190. The 2 into 190 will give us 95. So 95 times 1 will give us 95 there, plus then 95 into 195 will give us 2, right? There 2 times 37, that will give us 60, that is 74. That will give us 74, so I have here 74. Let me write it where 74 here. So we can add up here now. So this will give us 9, and this will give us 169, all over 190. All right, so therefore, the simplification of everything here is equal to our 169 all over 190. So this is the final answer to this basic simplification. So we have a simplification of this kind, start from the bottom, then upward. Okay, so this is how you simplify this upward. Look at this question before us here. About a year and a half ago, I solved this challenge, and I took time to look at this question again because I formed a habit of going through my old videos to see if there is any error. Okay, and I discovered a very little error, a slight mistake, okay, in that video. So I have to take down that video, and I want to reproduce that video and solve it the normal way. Although I got the correct answer at the end, but just because of a line, I just have to take that video down because we are not here to mislead any person here. So the question is m to the power of 4 minus 5 to the power 5 times m to the power of 2 equal to 36. What is the value of m? We have to solve for 4 possible routes to this challenge. Okay, because the highest power of m or the variable is 4. So let's take our solution here. Okay, so you just have to watch from the beginning to the end of this video because there is a special approach I'm going to apply in solving this here. Now, the question is m to the power of 4 minus 5 m to the power of 2 equal to 36, right? Good. Move this 36 to the left-hand side of the equation. So this is going to give us m to the power of 4, then minus 5 m to the power of 2 minus 36 equal to 0. Okay. So with this, we just have to rewrite this m to the power of 4. In other words, I want to bring in another alphabet to represent our m to the power of 2 and m to the power of 4. How do I mean? Now, I want to bring in, I like using t all the time. So let's say let t to the power of 2, or let's just say ordinary t first, okay? Ordinary t, let ordinary t be equal to our m to the power of 2. So, because we have m to the power of 2 represented by t already, so we have to bring in a quantity that will also represent this m to the power of 4 and must be that same t. And so we go to square both sides. This is going to give us t to the power of 2 will now be equal to m to the power of 4. With this, we want to represent our m here to the power of 2 with t, the m to the power of 4 with t to the power of 2. So rewriting this expression, this now implies our t to the power of 2 minus 5t rather. Pardon, please. So 5t, right? Then minus 36 equal to 0. So what kind of equation is it? This is a quadratic equation, right? In t. So we can use the factorization method to solve this. And how do I mean? We think from the factors of 36, two numbers that when we multiply together will give us minus 36. Their summation will give us minus 5. So let's begin to think. That will give us something 9 and 4. Okay? So, but what will now be the sign? It's going to give us minus 9 plus 4. Yeah, minus 9 plus 4. So this is going to give us our t to the power of 2. Then minus, let's take our 9t there plus our 4t minus 36 equal to 0. So from here, we can put this in bracket, also put this and this in bracket. We factor out terms that are common to each of these brackets. Here we have t common. So we have here t bracket t into t squared will give us t minus, we're left with 9 here, there plus what is common here is just 4. So bracket here 4 is left out, and here 4 into 36 will give us 9 plus bracket, this is equal to 0. If you check the terms that are inside the bracket, you'll discover that this and this are the same. So what we do, we take this one and this one that is outside and one of these ones inside. So this is going to give us our t there plus our 4 close bracket, 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 t minus our 9 close bracket equal to 0. Oh, that's good. So from here, there is a special law we're going to apply, which says that if you have your a times your m equal to 0, it means that your a is equal to 0 or your m is equal to 0. So if either a is equal to 0 or m is equal to 0, we can apply that. So here we can send this to this side, send this to this side, right? Good. But here comes the special trick I want to apply again now. I don't want to do that. Remember what we did here now. So I want to bring in the value of t, not t squared, into this and this. Easy. So if I bring it here and here, what would that look like? Okay, so this is going to give us, this now implies, bracket, what is our t? T is m to the power of 2. So we're going to have here m to the power of 2, then plus r4 close bracket, bracket. Again, t is m to the power of 2 minus 9 close bracket equal to 0. Do you see the uniqueness of this approach? Yeah. Again, we could as well solve this by equating this to 0, equating this to 0. But I said I don't want to use that method. Let's get something fresh, something new. So, because this is to the power of 2, this is to the power of 2, 4 is a perfect square, 9 is a perfect square also. So let's go ahead and rewrite this. So this is going to give us our m to the power of 2 plus 2 to the power of 2, close bracket, bracket, our m to the power of 2 minus 3 to the power of 2, close bracket, equal to 0. Here we have what we call difference of 2 square. We all know difference of 2 square, right? What does it say? It says that if you have your x, okay, if you have x to the power of 2 minus y to the power of 2, this will give us our x plus y, close bracket, bracket, our x minus y. We all know this, right? Good. We also have what is called sum of 2 square. What does sum of 2 square says? It says that your x to the power of 2 plus your y to the power of 2, this is equal to, because we can rewrite this expression here by bringing iota. We know that the square root of minus 1 is equal to iota, so we can bring that into this system. And if we do that, this is going to give us bracket your x plus iota y, then bracket your x minus iota y. How? I believe you've seen this before now. So we want to rewrite this using sum of 2 square and this other side using difference of 2 square. So with that, this is going to give us our m, then plus our, let's write the figure first, which is 2 iota bracket our m, then minus 2 iota, right? Then we come to this side, yeah, this is going to give us our m plus our 3, then bracket, bracket, m minus our 3 equal to 0. Okay, so we have our 4 roots playing out here now. 1, 2, 3, 4. Now, look at this law here. We're going to apply this law. Equate this to 0, equate this to 0, equate this to 0. So it means that the first one we're going to have m plus 2 iota is equal to 0, or m minus 2 iota is equal to 0. Then the second one, we're going to take this to 0, take this to 0. So this is going to give us our m plus 3 equal to 0, or our m minus 3 is equal to 0. So quickly send this to this side to give us minus, this to give us positive, this to give us minus, this to give us positive. So what are the values of m from here? It is clear. So this now implies that our m is equal to minus 2 iota, then, or we have our m is equal to positive 2 iota. Down here we have our m is equal to minus 3, then, or here we have our m is equal to positive 3. So let's bring that out in a well-organized form. So we're going to have here our m1. Let's take the positive one. So we have here 3. Then our m2. Let's take the negative minus 3. Then our m3 is equal to, let's take the positive imaginary part. So we have here iota. Then our m4. This is equal to minus 2 iota. All these values satisfy the original equation. So these are the values of m that actually satisfy these fourth power or fourth degree polynomial equation. Check out this radical equation. We can solve this radical equation or this kind of radical equation using 2 different methods. We can either move this quantity to this side, then square both sides of the equation, and then we simplify. Again, we can equally square both sides of the equation, and then we simplify. I prefer squaring both sides of the equation straightforward. So how we solve this? Let's take our selection first. All right, so we take our question here. Like I said, I want to square both sides of the equation and see what that gives us. All right, so this is going to give us the square root of minus t, then plus the square root of t, all raised to the power of 2 equals to 2 to the power of 2. Why are we taking the square of both sides because we're having a square root radical here and a square root radical here. Okay? All right. So with this, if we open up this expression, remember the expression which says that when you have a quantity of this kind, if you have your x, let's take x, then plus y, all raised to power 2, this is equal to our x to the power of 2, then plus our 2xy, then plus y to the power of 2. Remember this? Good. So with this, we can rewrite this side of the equation. This side doesn't have issue. This side is just 4. Okay, this side of the equation is just 4. So this is going to give us the first term, which is the square root of minus t, right? We said all raised to the power of 2, which is this. There's plus our 2 times the square root of minus t times the square root of t, right? Of t, okay? Then plus our square root of our t all raised to the power of 2 equal to r4. Right. Now, this we go with this radical and this radical we go with this. We all know that? Right. So this is going to give us minus t plus our 2 because this is square root radical, square root radical. So according to the law of surd, two of them can come together. So this gives us our minus t times rt, right? Then plus our t equal to r4. We're having minus t plus t on this other side. So this and this can leave the system. We're now left with our 2 into the square root of, if we multiply these two together, this is going to give us minus t to the power of 2. This is equal to r4. Here, something is playing out. We can divide through by 2. Okay? So this will now be divided by 2. We equally divide this by 2. This leaves 2 here, 1, 2 here, we have 2. So we're now having the square root of minus t to the power of 2. This is equal to r2. Now look at this. Here comes a little confusion, but it's not a confusion by the way. Now look at this. There's a video I made on this channel where I said if you have minus x to the power of 2 is not equal to your bracket minus x all raised to the power of 2. These are two different entities. Okay, so if there are two different entities, it means we can rewrite this expression we have here in another format. So this minus 1 is standing on its own, so we can rewrite this as our minus 1 then times the square root of t to the power of 2 then equal to our 2. Now recall that the square root of minus 1, the square root of minus 1 is equal to our positive iota, where iota is imaginary, right? So if we bring that into the system, this will give us something unique, right? So this is going to give us our iota times the square root of our t raised to power of 2. Again, the square root of t, this can go with this, but let's just continue first and see. So if we do this, what happens? This will go with this. I'm going to have iota times our t is equal to our 2. Okay, it is not it, all right? This is iota times t. So let's divide by iota. We call it divide this by iota. This leaves. So now having our t is equals to 2 all over iota. Simple, right? Good. But we have to do something. We have to kind of eliminate this iota at the bottom. And so we multiply everything by 1. And 1 is the same thing as your iota all over iota, right? So this will now interrogates us 2 all over iota times iota all over iota. So if we continue in this is going to give us 2 iota all over iota to the power of 2. Look at the relationship we have here. If we decide to square this part like this, and we decide to square this part, so this is going to give us minus 1 is equals to iota to the power of 2. Okay, so we are having here iota to the power of 2. So we can bring in minus 1 into the system. So this is going to give us our 2 iota here all over minus 1, which is equivalent to minus 2 iota. Right? Good. So we now have here, therefore, our t is equal to minus 2 iota. Wow. So this is the value of our t. So if we substitute this into the system, that will give us our positive 2. And again, having this as one of the roots, so positive 2 iota will also be a solution. So we also have t will equally be our 2 iota. So these are the two roots that actually satisfy these radical equation amidst the millions of solutions or roots to this challenge. Hello and welcome to today's math class. Today we have this challenge here. Okay, it's a rectangle triangle, and the sides are given using a symbol, the lambda. Okay, so yeah, AB is given to be lambda, and AC is given to be lambda to the power of 3, and BC is given to be lambda to the power of 2. So what is the value of lambda in meter? Okay, so I want to solve for the value here and the that of here and that of here. In other words, just to look for the value of lambda. So how do we solve this? All right, so we take our solution here, right? Okay, so now what we think here, or what comes to mind, because this is a right angle triangle, and so Pythagoras theory comes to mind, right? Okay, it says that when you have a right angle triangle, say the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent. We all know that from our elementary mathematics. And so this can be written as our lambda, which is the hypotenuse to the power of 3, all raised to the power of 2 is equal to the opposite here. Okay, well, let's start with this here, which is here the adjacent to the power of 2 all squared there plus our opposite square. This is Pythagoras theorem. We all know that, right? Now, according to the simple rule in indices, which says that when you have your a to the power of your m n, this is same thing as your a to the power of your m, or in bracket raised to power n. Okay, so we can use this to multiply this. So if we do that, this is going to give us our lambda to the power of 6, then equal to our lambda to the power of 4, then plus our lambda to the power of 2. Move these quantities on the right hand side to this side of the equation. Okay, so this is going to give us lambda to the power of 6 minus lambda to the power of 4, then minus lambda to the power of 2 equal to 0. So you discover that lambda to the power of 2 is common to everything here, so we can factor that out from the system. So let's factor that out and see what that will give us here. So from here, we're going to have our lambda to the power of 2 bracket. If we use that to divide this, we are left with lambda to the power of 4, then minus lambda to the power of 2, then minus 1, close bracket, this is equal to 0. All we just need to do is to apply the rule which says that when you have your A times your B equal to 0, this means that your A is equal to 0 or your B is equal to 0. Okay, so we apply this rule here. It means that our lambda to the power of 2 is equal to 0, which now implies that our lambda from here is equal to 0. But we are dealing with length, okay, as a dimension. And so if we substitute 0 here, substitute 0 here, substitute 0 here, everything will give us 0 here. So no plane shape will exist there, okay? So no figure will exist there. And so this solution is rejected. So we discard this, okay? So this is rejected. So we take the second case scenario, which is this. So we take this as our case 2. In our case 2, we have our lambda to the power of 4, then minus lambda to the power of 2 minus 1 equal to 0. This is a 4-degree polynomial equation. So we have to look for 4 roots to this challenge here. But here we are having 2 in here. We just have to rewrite this, okay? We can solve this using 2 different methods. Okay, we can bring in another figure that can replace minus 1 here, and we split it into 2, then marry it with this and this, right? Okay, but here we just have to rewrite this, which is the easiest step. So rewriting this could be written as our lambda to the power of 2 all raised to the power of 2, then minus our lambda to the power of 2 minus 1 equal to 0. Now, we bring another alphabet to represent our lambda here. So here, let's take it. So let x be equal to our lambda to the power of 2. So if lambda to the power of 2 is equal to x, what we do here is to substitute. So if we substitute, this now implies that our x to the power of 2 then minus our x minus 1 equal to 0. So we've reduced the fourth degree polynomial equation to a second degree polynomial equation, and this is a quadratic equation. We can solve this using the formula method. So using the formula method, all we need to do is just to state our formula in x. So we have x is equal to minus b plus minus the square root of b squared minus 4ac, everything all over our 2a. What is our a? Our a is the coefficient of x squared, so we have a is equals to 1, and our b is the coefficient of ordinary x, and our c is the constant x, which is minus 1. Let's go ahead and substitute these values into this expression. So we have x will now be equal to, what is our b? B is, I said minus s, sorry, it's minus 1, please. Yes, it is minus 1 because it is the coefficient of x here. So we have here minus bracket minus 1 bracket plus minus the square root of minus 1 all raised to the power of 2 minus 4 times 1, the times minus 1. All right, all over 2 times 1. Easy, right? Good. So let's continue on this side here. All right, now let's look at this. Let's open up this. This is going to give us our x minus, equal to 1 plus minus here, the square root of our 1 there, plus our 4 all over 2, which is equals to 1 plus minus the square root of our 5 all over 2. We have two values of x here now. So what are the two values? We have 1 plus the square root of 5 all over 2 as the first one, which is the golden ratio, and we have 1 minus square root of 5 all over 2, and that will give us a negative value. Again, we are dealing with length, and so that second solution will be discarded. So we're going to accept our x equal to 1 plus the square root of 5 all over 2 only. All right, now remember we did a substitution where we said let x be equal to lambda to the power of 2, right? So from here we say recall. So if we recall that we said our lambda to the power of 2 is equals to x, so we can easily bring in here our lambda to the power of 2 is equals to 1 plus the square root of 5 all over 2. So what we do here, we take the square root of both sides again, take the square root of both sides, this we introduce plus minus, this will leave. So we're going to have here our lambda. Let me draw this very well, please. Okay, so we're going to have our lambda will now be equal to, again, we are going to have minus here, plus minus. We are going to discard that second root again. So we take only the positive. So this is going to give us the square root of our 1 plus the square root of 5 all over 2. If you impute this into your calculator, this square root is covering everything down here. Okay, so if you impute this into your calculator, this will give you around 1.272. Okay, so we can say therefore lambda is approximately equal to 1.272 meters. So that is the value of lambda that actually satisfies this expression. Yeah. So to get the value or this length here, this will give you 1.272 meter, and this raise 1.272 meter to the power of 3. Here you raise 1.72 meter to the power of 2. Whatever it gives you, that is the correct value for the hypotenuse, adjacent, and the opposite. When you have a question of this kind, how do you approach it? The question is 8 to the power of x equal to 5 to the power of bracket open 2x minus 1 close bracket. What then is the value of x that will satisfy this challenge here? When you have a challenge of this kind, how do you approach it? This is pretty easy. Okay, we just have to rewrite this part of this equation because here we are having 8 to the power of x already. So let's keep the left-hand side of the equation and treat the right-hand side of the equation first. Now, I'm going to apply some simple rules in indices in simplified this. Now, this expression could be written as, so let's take our solution first. So here we have our a to the power of x is equal to, this very well could be written as our 5 all raised to the power of 2x times 5 all raised to the power of minus 1. How and why? According to the law of indices, it says that when you have your a all raised to the power of m times a to the power of n, this is equal to your a all raised to the power of m plus n. But here, the power of n here, according to this expression here, is negative. And that's why we are having this raised to minus 1 here. Look at it here. Okay, because if we sum of 2x plus minus 1 is going to give us 2x minus 1. All right, now we can rewrite this very one here, 5 to the power of minus 1, by eliminating the minus at the exponent. How? Another law which says that when you have your a to the power of minus m, this is same thing as 1 all over your a to the power of m. And so the minus is being replaced by 1 and this division sign. Okay, so going ahead to rewrite this, we're going to have our 5 to the power of 2x times 1 all over 5, all to the power of 1, which is same thing, right? Good. Now, with what we have in here now, what we do, it is pretty easy. We can either eliminate these 5 in here. And how do we eliminate these 5 here? We multiply both the left-hand side and the right-hand side by 5. So let's go ahead and do that. So this is going to give us our a to the power of x times 5. This is equal to 5 to the power of 2x times 1 all over 5 times 5. This will leave, right? So we now have our 5 times a to the power of x equal to our 5 to the power of 2 or 2x, right? Now look at this expression we have here now. We are having a to the power of x. Here we are having 5 to the power of 2x here. There's something I want to do in here. I want to separate these two from this x here. So according to the law of indices again, which says that when you have your a to the power of your m, n, this is same thing as your a to the power of your m, or in bracket raised to n. So I can separate these two from this x here. And so this is going to give us our 5 times a to the power of x is equal to our 5 raised to power 2 or raised to power x. Easy. So what we do next here is this. We want to divide through by a to the power of x. So if we divide this by a to the power of x, we equally divide this by a to the power of x. So this leaves the system. So we are now having our 5 is equal to, check out these powers of the quantity we have on the right hand side. Here is x, here is x. Again, if we apply the rule, we say that if you have your a to the power of your m all over b to the power of your m, this is same thing as a all over b all raised to the power of m. And so we can rewrite this. So writing this is going to give us our 5 to the power of 2 all over 8 all raised to the power of x. Right. Now let's check out this again. Yeah, 8 can be written as 2 to the power of 3. So let's go ahead and rewrite this. So we're going to have our 5 is equals to our 5 to the power of 2, okay, all over 2 to the power of 3, all raised to the power of x. We are looking for x. So let's bring the quantity having the variable to this side. And so if we do that, this is going to give us our 5 to the power of 2, all over 2 to the power of 3, in bracket, all raised to the power of x is equal to our 5 here. Good. The powers here are different. Okay, so there's no way we can bring them out. And so what we do here is this. We just have to ln both sides of the equation, or we can take log to base 10. So I want to take log to base 10 from this expression here. All right. Or better still use ln. Okay, let's take log. So we have here log our 5 to the power of 2 all over 2 to the power of 3, or in bracket raised to the power of x base 10. This is equal to log 5 here, the base 10. Easy. So we apply a law in logarithm which says that when you have your log p to the power of t, then move this thing back to give us rt times log p. So we want to move this power back here to give us our x times the log of our 5 to the power of 2 all over 2 to the power of 3, or in bracket base 10 is equal to log 5 base 10. Easy. Now, if you check out these 10 here, we are looking for x. So we quickly divide by log 5 to the power of 2 all over log 2 to the power of 3. Right? So we're going to have our x standing on its own is equal to the log of 5 base 10 all over the log of 5 to the power of 2 all over 2 to the power of 3, or in base 10. Easy. All right. Now what we do here now? 5 here cannot be simplified down beyond this. Okay. Now look at our the expression we have here. This is division, and we have a law to that in logarithm. The law which says that if you have log your m all over n, this is equal to log your m minus log your n. We call it the division law of logarithm. So we can apply it here. So if we do that, this is going to give us our x will now be equal to the log of our 5 base 10 all over our log of 5 to the power of 2, right? Base 10 minus the log of 2 to the power of 3 base 10. All right. So the power law of logarithm, have we looked at that? Yes. Look at the power law of logarithm. We're going to apply it here again. So this is going to give us our x will now be equal to the log of 5 all over 2 times the log of 5, right, base 10 minus 3 times the log of 2 base 10. Wow. So this is the final value of x that will satisfy this challenge here. We can get the numerical values by, simplifying this. Impute this in your calculator, impute this in the numerical values, divide, and then you get your answer. Again, you can still simplify this expression down, but for the sake of this class or the purpose of this class, I'm going to stop here. But again, if you want me to still simplify this down, then drop it in the comment section. I just quickly say simplify down. Okay, but for the purpose of this class, this is where I draw the curtain. Okay, so this is the value of our x that actually satisfies this challenge here. Hello, my great people. Welcome to today's class. Look at this radical equation. It's a cube root radical. The question is the cube root of minus t plus the cube root of t equal to 1. What is the value of t here? All right. Now let's see how we solve this. We take our solution first thing. If you're new here, do not forget to subscribe. And when you subscribe, turn on the bell notification button so that you get notified whenever we drop an amazing video. All right. Now, what do we do here at first? Look at this challenge here now. I want to move this quantity to this side of the equation. Okay, so this is going to give us the square cube root rather of minus t is equal to 1 minus the cube root of rt. Good. Now, because this is a cube root radical, we want to take the cube of both sides of the equation. All right, so we have here to the power of 3, we equally do same to this other side. And so what happened, this and this will leave, right? Then let's expound this using the binomial expansion. So we are looking at the third power. And let's get the coefficient for the third power using the Pascal triangle. So to the power of 0, we're going to have the coefficient to be 1 here. And to the power of 1, we're going to have 1, 1. And that of 2, we're going to have 1, then 2, because 1 plus 1 will give us 2, then 1. And that of 3, we're going to have 1, then 1 plus 2 will give us 3, then 2 plus 1 will give us 3, then we have here 1. So we are dealing with this coefficient here now. All right, so expanding this side of this expression, we're going to have our minus t will now be equal to, the first quantity here is 1. So this is going to be raised to power 3. So we have 1 to the power of 3, then plus this second quantity, it will be raised to power 0. And so that will give us 1. And so if we go to the next stage, we're going to have the coefficient, which is 3, then times, let's put a square bracket here, then what is our 1? Our 1 will be raised to power 2, then times, let's put our dot here, times the second quantity here is going to give us the cube root, but here we have a minus, so we have here minus the cube root of t, yeah, all raised to the power of 1. So we close this. Then we go to the next quantity, which is also having a coefficient of 3, then into a square bracket. 1 will be raised to power 1, then times bracket. Here, we still have a negative cube root of t. So we have here the negative cube root of RT. This time, it will be raised to power 2. Okay, then close our bracket. Then plus, yeah, the third one, which is, first, second, third, fourth term, 1 will be raised to power 0, which is going to give us 1, and it will leave the system. Meanwhile, this term will now increase in power to 3. And so we will have a coefficient of 1. So this is going to give us minus the cube root of t all raised to the power of R3. Easy. Yeah, when we have minus the cube root of t raised to the power of 3, then this power will affect this because this is minus 1. So minus 1 to the power of 3 will give us minus. And so cube root of t raised to the power of 3, this and this will leave. So we are left with minus t. So on this side, we're going to have here minus t will now be equal to 1. Then this minus here will come out of the system to give us minus 3 into the cube root of our t. Okay, then we come to this other side. This 1 times everything will give us the same. But these two, we multiply this minus 1 into 2 times, that will give us positive. And this, we multiply this. And so we are now left with our plus 3, then times our 3, that is cube root of t all raised to power 2. The minus, here we have minus, like we said before, minus t here. All right. Now look at this system here. We are having minus t here, we are having minus t here. So two of them will leave the system. Okay, so we now have 0 equal to everything else. So let's write it out first. 0 will now be equal to 1, then minus R3 into the cube root of RT, okay, then plus R3 into the cube root of RT to the power of 2. Okay, so what we do here now is easy. We want to, again, move this quantity here, only this quantity with a sign to this side of the equation. So let's move this here. This is going to give us our 3, then into the cube root of RT. This is equal to, on this side, we are now left with our 1, then plus our 3, then into the cube root of RT all raised to power 2. Let's continue here. All right. Now, from what we have here now, we are having the cube root of t, and we're having the cube root of t here. So we bring another alphabet to substitute for cube root of t. So from here, we want to say here, let the cube root of t be equal to, let's say, p. I like using p. All right. So wherever we see cube root of t, let's put in p. p there. So this is going to give us our 3p equal to 1 plus our 3p to the power of 2. So if we rearrange this is going to give us our 3p to the power of 2 minus 3p there plus r1 equal to 0. This is a quadratic equation, right? So how do we solve this for the value of p? We use the formula method, and the formula method says that our p will now be equal to minus b plus minus the square root of b squared minus 4ac all over 2a. All right. Now, we bring out our a, b, and c. From this equation, our a is equals to 3, our b is equals to minus 3, and our c is equals to 1. So let's substitute in and see what this gives us in turn. So we're going to have p will now be equal to minus our bracket minus 3 close bracket plus minus the square root of our minus 3 all raised to the power of 2 minus 4 the times what is our a here? Our a is 3, so times 3 times 1 everything all over 2 times 3. So let's check this out here. So this is going to give us minus times minus, we have 3, the plus minus the square root of 3 to the power of minus 3 to the power of 2 will give us 9, then minus 4 times 3 will give us 12, times 1 will give us 12. Everything all over our 6. Simplifying down, this will give us 3 plus minus the square root of 9 minus 12 will give us minus 3. So we have here minus 3 all over our 6. All right, so let's continue here. So what is our p now? We can split this, but before then, we can rewrite this minus 3. Remember that the square root of minus 1 is equal to what? Iota. So we can rewrite this and bring iota into the system. So this will give us our p is equal to our 3, then plus minus iota root 3 all over 6. Simplifying down, this will give us 3 all over 6 plus minus our iota root 3 all over 6. 3 here 1, 3 here 2. So we now have our P1. So P1 is equals to 1 all over 2 plus our iota all over 6 root 3. And we have our P2 is equal to 1 all over 2, then minus iota all over 6 here, right? The root 3. Now, these are the two values of our P. But we recall a place where we said, let P be something. Yeah, we said, let cube root of T be equal to P. So we're solving for the actual value of T. So how do we get the value of T? So we're going to substitute each of these values into this expression here. So let's continue here and see what this gives us a turn. All right, before we continue, if you've not subscribed, subscribe to this channel. Okay, now let's continue. Now from here, we said something that the cube root of RT should be equal to our P. So let's take this as P1. And we're taking this first one here now. So if we replace that, this is going to give us our cube root of T is equal to our 1 all over 2, the plus iota all over 6 root 3. Okay. We have to take the cube of both sides of the equation. So raise this to power 3, and we equally raise everything here to power 3. And so this and this will leave. So we now have our T will now be equal to, now if you use binomial expansion again to open up this, or which I have done that already, then this will give you 0.1924 dash to 988 iota. So this is our T1. Okay, so how do we get our T2? We're going to get our T2 from P2. Okay, so we have our T2 will now be equal to, if we substitute that into this system again, then we're going to have the same answer, but this time it's going to be negative 0.1924 dash then 988 iota. All right, so these are the two values of T that will satisfy the original radical equation. Okay, so if you learned something from this video, drop it in the comment section. If you've not yet subscribed to our channel, do so, because here we drop videos all the time. Thank you for watching. Thank you for being there. We have this challenge here on the board, and the question is 8 to the power of x equal to 100. What is the value of x here? All right, so we take our solution. So yeah, let's solve this challenge here. How do we solve for the value here? The first thing we do is to reduce 8 to the smallest base or the lowest base. And so 8 could be written as our 2 to the power of 3. Okay, then let's put this in bracket to separate it out from our x. Then our 100 can be written as our 10 to the power of 2. All right, now with this, we can use this to open this. Applying the law, we say that your a to the power of your m times n is equal to your a to the power of m, or in bracket to the power of n. Okay, so if we do that, this is going to give us our 2 to the power of 3x is equal to our 10 to the power of 2. Okay, now with this expression we have here, we cannot break these to base 2, right? So the only thing we can do here is to ln both sides of the equation. So if we ln both sides, it's going to give us the ln of 2 to the power of our 3x. This is equal to the ln of 10 to the power of 2. Okay, so here we're going to apply the law of indices, law of logarithm. We say that if you have the ln of your a to the power of b, move this back, this is going to give us b times the ln of ra. So we're going to move this back, and if we do that, this is going to give us our 3x times the ln of 2 is equal to 2 times the ln of 10. Okay, now with what we have here, it is simple now. Now we can rewrite these 10 here as 2 times 5. So let's rewrite this first. So we have 3x times the ln of 2 is equal to 2 into our bracket the ln of 2 times 5. Here we apply the multiplication law of logarithm, which says that your ln of a times b is equal to, let's put this in bracket, is equals to the ln of a plus the ln of b. So we just have to rewrite this side to give us 3s times the ln of 2 is equal to our 2 into the ln of 2, then plus 2 into the ln of 5. We just have to divide by ln of 2, divide everything here by ln of 2 also. So this will leave the system. Let's continue on this side. Now we are now left with our 3x will now be equal to, we can rewrite this expression we have here. This is same thing as our 2 ln of 2 all over ln of 2, which is for this, then plus our 2 ln of 5 all over ln of 2. This will also leave the system, right? So we now have 3x is equal to our 2 plus 2 ln of 5 all over the ln of 2. Okay, now we have to divide everything by 3 because we are looking for x. So we divide this by 3, then we divide the whole of this by 3 also. So this will leave. So we now have our x will now be equal to our 1 all over 3 into 2 plus 2 ln of 5 all over the ln of 2, close bracket. Okay, so this is the value of x, but we can get the numerical value of x from this expression we have here now. So if we simplify this, that is going to give us 1 all over 3 bracket our 2 there plus, if we impute this into your calculator, this is going to give you your 4.6, right? 4.614 times 4 rather, times 4 close bracket, okay? Then here we can add up this to give us our 1 all over 3 bracket 6.644. All right, if we use this to divide this, what would this give us? This is going to give us our 2.21, therefore, then approximately we're going to have this to be 6. So therefore, Rx is equal to 2.215 approximately, or let's leave it at 4.6. Okay, so this is the value of x. If you put this value up here, it's going to give you the approximate value to this challenge. Hi, again, we have this challenge here. The question is 8 to the power of x equal to 1. What could be the possible values of x in this challenge that can actually satisfy this? Now, if you are good at mathematics, you can tell straightforward that 0 is the answer to this challenge here. In other words, x is equal to 0. You are not far from the truth. That is correct. But do we have any other number that we can actually place in here, and when we evaluate it, it will give us 1? Yes. And I'm going to tell you for free that we have infinite numbers that we can put in place of x, and when evaluated, will give us 1. But the joy or the news here is that those numbers are going to be imaginary numbers. Okay, so what are these imaginary numbers that we can put in place of x, and when we evaluate it, they will give us 1? That is the excess of this video. All right, so sit back as we go on this journey. So we'll take our solution first. So we have your solution. All right. So we have our 8. Let's put it down here. 8 to the power of x is equal to 1. I know your mind will tell you that so long we are having 8 to the power of x here, we can align both sides of the equation or take log to base 10 of both sides of the equation. And if you do that, you're going to come up with just one solution, and that is x equal to 0. That's what you're going to have from here. But how do we solve this and be able to get all possible integers or values rather of x that will satisfy this challenge? It is easy. Let's take a look at the right hand side of the equation. We are having 1. Okay, we have to look at this more critically because we are looking beyond the real solution of this challenge here. So the real solution of x. And so for us to get that, we must look into the imaginary world. And for us to consider the imaginary world, we consider a special equation called the Euler equation. Now, what does this say? Euler equation says that your E is a special equation. E to the power of your pi I plus 1 is equal to 0. Then we want to move this one to this other side. And so this is going to give us our e to the power of pi I is equal to minus 1. Remember, we want to substitute something for this 1 here. So we've gotten e to the power of pi I equal to minus 1. So we have plus 1 here. So for us to eliminate this minus here, we have to raise this to 2k or 2n, where k is a set of constants or n is a set of constants, right? Now, I prefer using our k. So if we raise this, so this is going to give us our e to the power of pi iota all raised to the power of 2k is equal to minus 1 all raised to the power of 2k. Easy. We can rewrite this, right? We can write this in this format, that our minus 1 all raised to the power of 2 all raised to the power of k. And minus 1 to the power of 2 will give us what? 1, all to the power of k. Okay? So rewriting this is going to give us 1. Because we said k is going to be a set of constants. Okay? So this is going to give us, and again, we can use this to multiply this. Apply the simple rule of a to the power of mn is equals to a to the power of m bracket or raised to the power of n. So if we use this to multiply this, we're going to have our e to the power of 2k pi iota is equal to our 1, where k is a set of numbers 0, 1, 2, 3, dash to infinity. That is where we're going to have our infinite solution for our x here. All right, so let's go down and put the whole of this place in place of 1 here. So rewriting this is going to give us something nice here. So we're going to have our 8 to the power of x will now be equal to r e to the power of 2k pi iota. Good. Now, it is at this point we can now either ln both sides of the equation, that is ln base e, or we take log base 10 to this expression. But here, let's take our ln base e. Why? Because of this e we have in here now. So let's take this as our, so we have ln of 8 to the power of x. This is equal to the ln times our e to the power of 2k pi iota. Okay. We apply the law of logarithm, which says that your log, if you have, okay, let's take your ln of your a to the power of b, so move this way. So this is going to give us our b times the ln of a. So we want to move this x this way. So we're going to have here x times the ln of our 8. This is equal to, now if you take a good look at this, we're having ln base e times e. And so this will leave the system. And I'm left with our 2k pi iota. Wow. Now we divide through by ln of 8. So we now divide this by the ln of 8. We equally divide through by this side by ln of 8. This leave the system. So we now have our x will now be equal to, look at the ln of our 8 here. 8 can be written as 2 to the power of 3. Okay, so if we have 8 written as 2 to the power of 3, so we're going to have ln of 2 to the power of 3. Applying this law of logarithm, we're going to move the 2 to the other side. And so if we do that, this is going to give us our 2k pi iota all over our 3 ln of 2. Easy. Okay, now let's check out this now. Remember we said our k, look at the value of our k. We said k is equals to 0, 1, 2, 3, dash to infinity. Okay, so we're going to substitute the values of k into this equation and see what this gives us. So this is the original root where we're going to do our substitution. So we're going to take the value for the first one. I've done value for the first, second, third, and to the fourth one. And they all satisfy the original equation. But I'm going to do that of the first one. Okay? Then, when k is equal to 0, let's put 0 into this. So this is going to give us our x1 is equal to 2 times 0 times pi iota all over our 3 ln of 2. And this will give us 0 all over the 3 ln of 2. Okay? And everything will give us 0, right? Is that not so? Yeah, this will give us 0. So we're going to have x1 is equal to 0. This is the first value that even many looking at it, you will know that anything raised to the power of 0 is equal to 1, except 0 to the power of 0 and 0 to the power of iota. Outside these conditions, any other thing raised to the power of 0 will give us what? 1. Okay, so the first value here, we have x1 is equals to what? 0. Satisfy this. So let's just quickly check for that of our k equal to 2. So for our x2, for our x2, what will be the value of k? So we're going to have k is equal to 1 for our s2. So we're going to have x2 is equal to, we're going to put in 1 here. And so that will give us our 2 pi iota all over 3 ln of 2. So this is the value of our x2. Now, if you put this into your calculator, it will give you 9.0 something something iota. And if you put that value here, it will give you 1. Okay, so it shows that this also satisfies the original equation. Okay, if you do that for k3, k4, k5, k6, k whatever to infinity, you discover that you're going to have infinite solution to these, but only one of the answer or the root is a real root. The rest are from the imaginary word, imaginary numbers. Okay, all right, so see you in our next class. We have this simplification before us here. The question is simplify, bracket open 1 plus iota, close bracket, all to the power of 12. This is easy to simplify, right? Okay, this is how you go about it. So we have our 1 plus iota raised to power of 12. This can be written as our bracket open 1 plus iota all raised to the power of 2 square bracket raised to power of 6. Okay, because if we use this to times this, that will give us 12. So let's handle what we have inside here first. So if we do that, this is going to give us, this can be written as our iota bracket, our 1 plus our iota, okay, everything raised to power 6. If we simplify this, let's go gradually. This times 1 will give us our 1. 1 times iota will give us plus iota. We come to iota. Iota times 1 will give us plus iota. The iota times iota will give us plus iota to the power of 2 all raised to power 6. So we have here our 1, right? So from here, we can add these 2 here. So this is going to give us our 1 plus 2 iota. Now, iota to the power of 2 will give us minus 1. Remember that the square root of minus 1 is equal to iota. So if we square this side, we equally square this side, this will leave. So we're going to have minus 1 is equal to our iota to the power of 2. And so this is going to give us minus 1. So I have here minus 1 plus bracket raised to power 6. This will leave. So automatically we're going to have 2 iota all raised to power 6. Again, we can simplify this, right? Okay, so this is same thing as our bracket 2 iota to the power of 2 times this time times 3. Yeah, okay, so if we have this to the power of 2 times 3, then this is going to give us bracket our 2 to the power of 2 times iota to the power of 2 all raised to the power of 3. And this will end up giving us 4 times minus 1 all raised to the power of 3, which is equal to, this will give us minus 4, right? Yeah, it's going to give us minus 4 all raised to the power of our 3. And what is minus 4 to the power of 3? That will give us 4 minus 4 times minus 4 times minus 4. And that will give us minus 64. So this is equal to minus 64. So what does it imply? It means, therefore, that our bracket 1 plus iota raised to the power of 12, when simplified, will give us minus 64. And that is the answer when you simplify this. Very easy. Thank you for watching. See you in our next class. Hi, wonderful people. Welcome to today's class. Today we have this radical challenge before us here. It's a very technical one. Many looking at it, you may think it is easy to solve, but it may not be as easy as you may think. So we're going to do some substitution here, some replacement here, okay? And so I want you to pay closer attention to the steps I'm going to take in solving this challenge here. All right, so but before we go into today's challenge, if you're new here, kindly subscribe. And to my returning subscribers, we love you. My returning viewers, we love you. Thanks for being supportive. So the question is the cube root of 4x plus 49 minus the cube root of 4x minus 49 equal to 2. What is the value of x that will actually satisfy this radical equation? So first, we take our solution. Okay. Now, we're going to start off with substituting another alphabet for this first expression and a different alphabet for this. And so we're going to say here, let's take a p. I like using p. Let p be equal to the cube root of our 4x then plus our 49. Okay. Now, if we have our p to be equal to this, and we decide to take the cube of both sides, then it will expose this content we have inside here. And so this will now give us p to the power of 3 is equal to our 4x then plus our 49. Let's give this equation star. And let's give this equation 1. Okay? Good. Now, I said we're going to bring another alphabet to represent this. So here, let q be equal to our cube root of 4x then minus r19. All right. Now, with this again, we take the cube of both sides of the equation to expose this. So this is going to give us our q to the power of 3 will now be equal to 4x minus 49, right? Oh, where did I see 19? It's 49, please. So 49. We have 49. Let's give this equation star. Now, with this first substitution and this one we did here, we can rewrite equation 1. So our equation 1 will now becomes our p minus rq is equal to 2. Now, this is this equation we have in here now. And so let's give this equation 2. We have this to be equation 2. Okay? Again, we have equation 1, we have equation 2, we have equation star, we have equation star. Good. Now, from this, we want to subtract equation star from equation star. So from here, we now say here subtract equation star from equation star. Now, if we do that, what's going to happen? We're going to have p to the power of 3 minus q to the power of 3. So this now implies that our p to the power of 3 minus q to the power of 3 will now be equal to, here we're going to have our, look at our 4, then x minus, plus, okay, let's take plus our 49, then minus, let's put in bracket our 4x, then minus our 49. Right? So with this, we're going to have our p to the power of 3, then minus our q. This is equal to, this will give us 4x, then plus our 49, then minus 4x plus 49. So we have p to the power of 3 minus q to the power of 3. We now becomes, we have plus 4x minus 4x. So we are now left with 49 plus 49. And this will give us 98. So we have 98. So this is another equation again. Right? Good. Now look at the expression we have on this side. This is what we call difference of two cubes. What does it say? It says that if you have your a to the power of 3 minus b to the power of 3, then we have bracket open your a minus b close bracket your a squared, then plus your ab, then plus your b r to the power of 2. This is what we call difference of two cubes. So we want to write the left-hand side of this expression in this format. So doing that is going to give us this. Let's continue. So this is going to give us our bracket p minus our q close bracket. We're going to have our p to the power of 2 plus our p q there plus our q to the power of 2 close bracket equal to our 98. Wow. Now, if you look at this expression closely, you'll discover we have P minus Q already. Look at it here as our equation 2. And it has a numerical value. P minus Q is equals to 2. Okay, now we can rewrite this expression here to give us here our P minus Q close bracket, P to the power of 2 plus Q to the power of 2 plus PQ, close bracket, equal to 98. We do not have any expression of this kind, which is P to the power of 2 plus Q to the power of 2. So what we do, we circle to another algebraic expression which says that your A, okay, to the power of 2, then plus your B to the power of 2, this is equal to bracket your A minus your B all to the power of 2, then plus your 2AB. Okay, so this expression here, we're going to rewrite in this format here. And so rewriting it is going to give us our P minus our Q close bracket into a square bracket, our P, then minus our Q all to the power of 2, then plus our 2 PQ, then plus our PQ that is already in existence here. Square bracket close equals to 98. Easy. I told you this is a bit technical, but we're going to get it. Yeah, we cannot add this and this together. We have the value of this, we have the value of this, and substitute. So this will now give us P minus our Q close bracket, the square bracket, our P minus our Q all to the power of 2 plus 3PQ equal to 98. So from equation 2, we can put in 2 in place of P minus Q here and here. If we do that, this is going to give us our 2, then into 2 to the power of 2, then plus our 3PQ, then close bracket equal to 98. Divide through by 2. Divide through by 2. And so this will leave, this will give us 49. So we now have our 2 to the power of 2 will give us 4. So we have 4 plus 3PQ is equals to 49. Wow. All right. We send this to this side quickly to give us 3PQ is equals to 49, then minus 4, and this will give us 45. Divide by 3, divide by 3. Cancel, cancel. So we have our PQ will now be equal to 3 here 1, 3 here 1, 3 to 15 will give us 5 is equals to 15. Now let's give this equation. So we are giving this equation 3. Let's give this equation 3. But before we continue again, if you've not subscribed, do us that favor by subscribing. And when you subscribe, turn on the notification bell so that you get notified whenever we drop an amazing video. The YouTube algorithm will notify you and you will be among the first to get our video watched. Now from this equation, we want to make Q the subject of the formula so that we can substitute that into equation 2. So from here, we now have our Q will now be equal to 15 all over P. Okay? 15 all over P. So let's give this equation star, star, star. From here, I want to put equation star, star, star into equation 2. So from here, we'll now say put equation star, star, star into equation 2. I say you have to pay close attention, okay? So let's erase this side and put the value of equation star, 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 which is this, into this our equation 2. So our equation 2 we said is P minus our Q is equal to 2. So our Q is 15 all over P. So we have here P minus 15 all over Q equal to 2. Cross multiply. Sorry, what am I writing? Is P, please? Yes, P. So if you multiply to eliminate this P here, it's going to give us our P to the power of 2 minus 15 equal to 2P. So if we rearrange, we're going to have P to the power of 2, then minus 2P minus 15 equal to 0. Okay, now let's look at this. We'll look for two quantities that when we multiply together will give us minus 15, add them together to give us minus 2. And that will give us minus 5 plus 3. Minus 5 plus 3. So using factorization method, we have p to the power of 2, then minus 5 minus 5p, then plus 3p, then minus 15 equal to 0. So we can put this in bracket, and factor out the terms that are common to both brackets. So here p is common here, so I have here p, here we'll give us p minus our 5 close bracket plus what is common here 3, so you'll have here p minus our 5 also equal to 0. So we take these because they are the same, so we have p minus our 5, okay, then bracket, here we have here our p plus 3 equal to 0. So this will give us p equal to 5 or minus 3. Okay, now but let's look at this. Here we don't have p in the beginning, and so we pick our equation star. Remember our equation star? Our equation star says that your p raised to power 3 is equal to 4x plus 49. Remember this? So let's take the first value of p. We have p1 here. So we're going to give us our 5 to the power of 3 equals to 4x plus 49. Then this will give us 125 equals to 4x plus 49. Move this to this side. This will now give you 4x is equals to 125 minus our 49. So we have 4x is equal to, if we subtract this from this, will give us 76, right? Yeah, to give us 76. All right, so divide by 4, cancel. The x will now be equal to, if we use 4 to divide this will give us 19. So we have positive 19. But again, we have our p to be minus 3. So we substitute for our minus 3. So this is going to give us our minus, what is happening here? Minus our 3 to the power of 3 equals to 4x plus 49. And so this will give us minus 27 equals to 4x plus 49. So move this to this side, gives us minus 27 minus 49 equals to 4x. Let's continue on this side. We're almost there. So this minus this will give us minus 76. So we have here 4x. For x is equals to minus 76. Divide by 4 again, divide by 4, cancel. So here we have minus 19. So we have x is equals to minus 19. All right. So we have our answer. So we have therefore, we can say therefore x1 is equals to positive 19 and x2 is equals to minus 19. These are the two values of x that will satisfy this wonderful radical equation. Hello, wonderful people. Welcome to today's math class. Today we have this challenge on the board before us here. The question is x equal to 2t plus 1 as equation 1 and y equal to t to the power of 2 plus t equal to our equation 2 rather. We are asked to look for the value of our y in this expression. And in this challenge or in this math class, we want to introduce ourselves to what is called a parameter. And a parameter in this challenge here is just an extra variable, okay? We have the x and the y variable here. So t is serving as an extra variable, okay? Now, in the context of the x and y coordinate or axis, what is a parameter? A parameter is a variable often represented as t or theta that defines the coordinates x and y of points or a curve where both x and y are expressed as functions of that parameter. Okay, both x and y are expressed as a function of that parameter. Look at what we have here now. Okay, so this is expressed as a function of our x and y. So that is the definition of a parameter. So here, t here is a parameter, right? But how do we now get the value of our y in this expression we have here now? Okay, that is just the sole aim of this video or this math class. Okay, so let's go into solving this equation we have here now, having known the meaning of a parameter. Okay, so take solution. All right. Now from equation 1, all we just have to do is to make the parameter the subject of the formula. So we can say from equation 1, so from equation 1, we want to make t the subject of the formula. So if we move this to this side, this is going to give us our x minus 1 equal to 2t. Just divide through by 2. So we divide through this by 2, 2. So we now have our t is equal to x minus 1 all over 2. So we have a new equation. Let's give this equation 3. So if we have this as equation 3, let's look at equation 2. Look at equation 2. We are having y equal to t to the power of 2 plus t. So we're going to substitute the value of t into equation 2. Okay, so we can now say here, put equation 3 into equation 2. So we write down our equation 2. Our equation 2 says y is equal to rt to the power of 2 plus rt here. So wherever we see t here, we want to put in equation 3 here, there, which is this, right? So this is going to give us our y will now be equal to x minus 1 all over 2 all raised to the power of 2, then plus x minus 1 all over 2. All right, so let's continue on this side here. So let's look carefully here. We just have to open this, okay? So opening this will give us our y will now be equal to our bracket x minus 1 all over 2 times our x minus 1 all over 2 plus our x minus 1 all over 2. Easy. So if we use this to open this is going to give us something. This time this will give us x to the power of 2. This time this will give us minus x. We come to this time this will give us minus x. This time this will give us minus times minus will give us plus. So we have plus 1, everything all over our 4, 2 times 2 here, right? So on this other side, we still have our x minus 1 all over 2. Easy. So what we do next here is this. We just have to add this together. So this is going to give us our x to the power of 2 minus 2x, then plus 1 all over 4, then plus our x minus 1 all over 2. Easy. We can strike a common denominator from here, right? So if we do that, that is 4. So if we have here to be 4, then 4 into 4 will give us 1. 1 into everything we have, you're going to have here x to the power of 2 minus 2x plus 1. Then 2 into 4 will give us 2. We use 2 to multiply everything we have in here, which is the numerator. So 2 times x will give us plus our 2x. Then 2 times our minus will give us minus our 2 here, right? So what you observe here is that here we are having minus 2x plus 2x. So this and this leaves the system. We're now having plus 1 minus 2. So we can simplify this out to give us our x to the power of 2, then minus 1 all over 4. So we can conclude by saying that therefore our y, which is what we're asked to look for, is equal to our x to the power of 2 minus 1 all over 4. This is the value of y. Y is equal to x to the power of 2 minus 1 all over 4. We did it based on what we call a parameter, okay? We try to handle this parameter, okay? Hello and welcome to today's class. Here we have this exponential challenge before us here. To what number are we going to raise 2 to give us 9? Now, if we take a simple look at our 2 here, we know that our 2 to the power of 0, this is equal to 1. And 2 to the power of 1 is equal to 2. Then 2 to the power of 2 will give us our 4. Then 2 to the power of 3 will give us what? Our 8. Then 2 to the power of 4 will give us our 16. Okay, so what does that imply? It means that the value of x here is going to fall within 3 and 4. But it's going to be closer to 3 because here we have 8 and here we have 16. So between 3 and 4, the value will be closer to 3. So we're going to have something maybe within 3 points, whatever. But how do we get this answer? Is the aim of this video. So we take our solution from here. So we have solution. All right, so we have 2 to the power of x equal to our 9. Now, with what we have here, now we are having 2 here as a base number. Then can we express 9 in base 2? It's no, but we can take it to base 3. So 9 can be written as 3 to the power of 2. And so we're going to have here 2 to the power of x is equal to 3 to the power of 2. Wow. They have 2 different base numbers. Okay, so we cannot equate the exponent here. But how do we approach this from this standpoint? We just have to log both sides of the equation. We can either take the ln base e or log base 10. But here, let's take log base 10. So we're going to log both sides. This is going to give us our log 2 to the power of x base 10 equal to log 3 to the power of 2 base 10. So this side of the equation is to the power of x, and this side is also to the power of 2. And so we're going to apply a simple law in logarithm, which says that when you have your log x to the power of y, take this y to this side to give y times log your x. This base 10, this base 10. Okay, so we want to apply that law to this and to this. So we're going to move this this way, move this way. So we're going to have here x times our log 2 base 10 equal to our 2 times log 3 base 10. Easy. We're looking for x. So x is already playing out here. We divide through by log 2 base 10. So we divide through by log 2 base 10. We probably divide this by log 2 base 10. So this will leave. We have our x standing on its own now. Now, this expression we have first, let's express our s here. So we have here 2 times our log 3, then base 10, all over log 2 base 10. We can get the numerical values of x from here. How? We can find the value of 3, log 3, then value of log 2, and when we divide, multiply by 2, it's going to give us something around 3 point a value. Okay, now if you put that there and you simplify, it's going to give you an approximate value. Now, I promise you that we're going to do a check on this root. But before we do a check on this root, we want to rewrite this answer to enable us to check the answer easily, right? Good. Now we're going to apply what is called the change of base rule to this expression we have here. The law which says that if you have your log, let's say you have your log A, then base B, you can change this to base C. And this is going to give us log your A base C, where C is the new base number, then all over the log of your B base C. So this is what we call change of base law in logarithm. And so we want to rewrite this answer here. So rewriting this is going to give us our x will now be equal to 2 times log 3 base 2. So this is the final way or form of expressing our x. Now, want to do a simple check. Want to put the whole of this expression in here and see if it will satisfy the answer. So we're doing the verification. So we are going to take here check. So check here, our question is 2 to the power of x is equal to 9. So whenever we see x, we want to put in 2 times log 3 base 2. Okay? And so this is going to give us 2 times, 2 raised to the power of 2 times log 3 base 2 equal to R9. We apply another law of logarithm, which is what we call the power law of logarithm, which says that if you have your log, okay, we've already written it here, right? We're going to apply this law here now by moving this one this way. So it's in this format. Look at our expression. It's in this format. So we want to take it back here. And so we want to move this 2 to this other side. So this could be written as 2 to the power of log 3 to the power of 2 base 2. Everything equal to 9 in here. Again, remember the law in a logarithm. Again, which says that when you have your log, let's take another alphabet. Okay, it says that if you have your a, okay, all raised to the power of log, your b, okay, let's take b base a, because here we're having a and here we're having log base a, this will leave to give us rb. So with this, look at here, we're having 2 to the power of log 3 to the power of 2 base 2. So this will leave. So we are now left with 3 to the power of 2 is equal to R9. And what is 3 to the power of 2? That is 9 equal to 9. All right, so this shows that the answer which we got, x equal to 2 times log 3 base 2, actually satisfied the original equation. Thank you for being there. Any question with regards to this, drop it in the comment section. See you in our next class.